We'll be seeing today perimeters and areas of similar figure. So let's start with the first slide. The two polygons below are regular pentagon. Are they similar figures? That's what is being asked. Okay. Uh, Tell via chat, are they similar? And what do you think? Do you think if they are similar or not? Or you can tell there is not enough information as well. Use chat to tell me whether these two pentagons are similar or not. They will be similar. I hope you remember the definition of similar figures. They have the same shape but they don't have to have the same size. And here all the angles will be congruent because it's a regular pentagon. Okay, it's a regular pentagon, which means all the angles of this particular pentagon, the first pentagon which is shaded, all the angles are congruent because it's a regular. So same way here all the angles are congruent. So you'll have these two figures to be similar. Yes. And next, what is the scale factor of the first pentagon to second one? Okay, the first pentagon to the second one, if I want to find out the scale factor, I just have to pick up any particular side of the first pentagon and divide it by the second pentagon. So in this case, the scale factor equals 10 mm divided by 7 mm. Okay, the next step is find the perimeter of each pentagon. What is the ratio of the first perimeter to the second one? Let's find out the perimeter. What is the perimeter? Perimeter is nothing but the sum of all the sides of the pentagon. So let me call this as pentagon 1 and let me call it as pentagon 2. Okay, so pentagon 1 P1 perimeter is nothing but it has 5 sides. It has 5 sides and each of them is 10 mm. So 10 plus 10 plus 10. I have to add all the 5 sides in this file because this one is 10, this one is 10, this one is 10 and this one is 10. I will end up getting 50 mm. Same way, perimeter of the second pentagon, there are 7. The length of the side of each side in this particular pentagon is 7 millimeters. So I'm adding 7 5 times. So I'll get here 35 mm. And now if I do the ratio of the first perimeter to the second one, if I do P1 is to P2 equals 50 divided by 35. Further I can simplify this as 5 times 10 and 5 times 7. So I'll end up getting 10 over 7. So I'll get P1 is to P2. The ratio is nothing but equals to 10 is to 7, which is same as the scale factor which we have. Okay, so scale factor is same as the ratio of their perimeters. That's what we are seeing here. Let's move on to the next slide. We already saw the property that whenever we have two similar figures, their perimeters will have the same ratio as the scale factor. Using that, I want you all to try this particular problem. The perimeter of rectangle is 28 centimeter. A similar rectangle has side lengths of 12.5 centimeters and 17.5 centimeters. What are the side lengths of the original rectangle? Okay, try this particular first problem. I will go over solution in another minute or so. Okay, take a minute and try to get this. Okay, let's construct both the rectangles. So first of all, let's try to draw those rectangles. That will help us. In the first rectangle, I don't have the length, I don't have the width, but I have the perimeter of this particular rectangle. 28 centimeters. A similar rectangle. In the second rectangle I have, this is my rectangle 1, I'm just calling R1, and this one let me call it as rectangle 2. They have given us the length 17.5 and the width 12.5, which means I can find perimeter. Perimeter in this particular case is nothing but equal to 2 times of 17 plus 5, 17.5 plus 12.5 using 2L plus 2 times of L plus W. Okay, so 17 plus 17.5 plus 12.5 gives us 30, and 30 times 2 gives us 60. So the perimeter of second rectangle is 60. We saw from the previous slide that the ratios of the perimeters of two similar figures will be same as the corresponding lengths or corresponding sides of those particular figures. In this case, L corresponds to 17.5, so I'll write L over 17.5. Same way this can also be W over 12.5. Okay, here I mean perimeter of rectangle 1. Perimeter of rectangle 1 was 28, so 28 divided by 60 equals L over 17.5. Okay, first scenario, let's complete, let's get L, and later on second time you can take 28 over 60 equals W over 12.5. Okay, further cross multiplying here on the first, I'll get here L equals 28 into 17.5 over 60. If I further simplify, I'll get 60L and divide by 60 on both sides. So first I'll get 60L equals 28 times 17.5. Then dividing by 60 on both sides, I'll get L equals 28 times 17.5 over 60. Let's simplify this to get our L. 28 times 17.5 gives us 490, dividing by 60 gives us 8.167. And the unit was centimeters, so I'll just keep centimeters. To get the width, once again I'll have to multiply 12.5 with 28, so just compare these two to get the width. Okay, these two, so once, so 28 times 12.5 equals 60 W you'll get, so dividing by 60 on both sides, once again you'll get W. 28 times 12.5 is 350, dividing by 60 I get 5.833. 5.833 centimeters. So these are my two answers. The width is 5.833 centimeters and the length is 8.167 centimeters. In the same manner, I just want you all to try the next problem as well. The polygon below are similar. If the perimeter of the smaller polygon is 25 feet, what is the perimeter of the larger polygon? Okay, you have once again a minute or so, then we will go over solution. Okay, same way here as well. The perimeter, let me call this as, we have it once again 1, 2, 3, 4, 5 pentagon, right? So perimeter of the first pentagon, perimeter of, I'm writing PER for perimeter. Perimeter of pentagon 1 divided by perimeter of pentagon 2 will have same ratio as the corresponding sides because they are similar figures. So I can write this as 6 over 16. If the perimeter of the smaller polygon, that is P1, is given as 25, so this one I know as 25, but I don't have the value of perimeter of the second polygon, perimeter of P2 equals 6 over 16. Okay, let's further cross multiply to get 25 times 16 equals 6 times of perimeter of the second polygon. Then divide by 6 on both sides. Dividing by 6 on both sides, I'll get the perimeter as perimeter for the second one. 25 times 16 is nothing but 400. Dividing by 6, I get 66.667. So perimeter of this particular larger polygon so first let me write here in terms PRP2 is 66.667. Perimeter of larger polygon is 66.667 feet. That given the units feet, so use that. Let's move on to the next slide. The two rectangles below are similar. What is the scale factor? Okay. Once again, use your chat to tell me what is the scale factor for these two rectangles. Okay. I can get two scale factors. If I want, I can get one of the scale factor as by comparing this particular side with this one. So let me do here 8 divided by 20 because they are corresponding side. If I do 8 divided by 20, I get 0.4. Same way if I do 14 divided by 35, I get 0.4. What does this 0.4 indicate? 0.4 is the scale factor. If I multiply to the second figure, I'll get the first figure. 0.4 is scale factor to get sides of first rectangle if the second rectangle is given. First rectangle with second, this is your first rectangle and this is your second rectangle. If they give you any side in the second rectangle and you multiply by 0.4, you'll get the first rectangle side. Scale factor to get sides of first rectangle where second rectangle's sides are given. So observe here, this was for figure 1. This side corresponds to figure 1 and this side corresponds to figure 2. Okay. When I do figure 1 divided by figure 2, I am getting figure 1. The scale factor to get figure 1 when the figure 2 is given. Same way I can get another scale factor. I'll do figure 2 corresponding side divided by figure 1. That is nothing but 20 divided by 8, which will also give you 1.35, and if you want you can check the other one also, 35 divided by 14, that will also give you 1.35. This is a scale factor when they give you a side in the figure 1 and you can get a corresponding side in figure 2 by multiplying 1.35. Okay, it's a scale factor to go from figure 1 to figure 2. In short, it's a scale factor by this I mean whenever they give you the any side in the figure 1, I can get the corresponding side in figure 2 by multiplying this particular scale factor. What is the ratios of the perimeters? Ratios of the perimeters will be same as the ratios of the scale factor. Okay, once again, and the ratios of areas we will see once we complete ratios of perimeters. So ratios of perimeter will be same as ratios of the scale factor. Let's see the areas. Okay, we will, as of now, we will just keep it to figure 1 is to figure 2. The ratios of perimeter of figure 1 divided by perimeter of figure 2. I'm writing in short form, perimeter of figure 1 is to perimeter of figure 2 will be same as the ratios of scale factor of from figure 1 to figure 2, which was nothing but 0.4. Okay, if you do perimeter of figure 2 or figure 1, you'll get 1.35. Both are correct. They have not mentioned from which to which, so you can just keep as of now figure 1 is to figure 2. What is the ratios of the areas? So area of the first one is 8 times 14. Area of figure 1, length times width, which is 8 times 14, that gives us 112, and area of figure 2 let's see area of figure 2, which is 20 times of 35, which is 700. Same way, let's compare here ratios of area of figure 1 is to area of figure 2. Let's see what we will have. 112 divided by 700 gives us 0.16. 0.16. If I do, let me write another step. If I do 112 divided by 700, I'll get 0.16. 0.16 is nothing but 0.4 square. So there is a pattern. There is a pattern. The ratios of the areas is the square of the ratios of the perimeter or the sides. Okay, you can see that ratios of the areas is nothing but square of the ratios of the perimeters or the ratios of the sides. So ratios of the sides was 0.4. The ratios of the perimeter was 0.4. Ratios of area is 0.4 square. Okay, you can keep this in mind, keep this particular note. Ratios of area is square of ratios of perimeter or perimeter or sides. Okay, that's what we observed, right? Keep that in mind, and using that we will solve some more problems. Let's move on to the next slide. The areas of similar polygon theorem. We did that already. If two polygons are similar with the lengths of the corresponding lengths in the ratios of A is to B, then the ratios of their areas will be in the ratio of A square is to B square. Okay, keep Make a note of this particular theorem. If the corresponding sides are in the ratio of A is to B, their areas will be the ratios of A square is to B square. Okay, let's see an example based on that. The ratios of the sides of the smaller trapezoid with the larger trapezoid is nothing but 12 is to 21. 12 is to 21. Okay. If two polygons are similar, the corresponding sides are in the ratio of 12 is to 21. And we want to find the area of the first trapezoid. Area, that we call this as area 1 and that we call this as area 2. Area 1 is to area 2 is nothing but equal to square of this particular corresponding side 12 square, and square of this particular corresponding side of the second trapezoid, which is 21 square. And I know the area of the second trapezoid here is 441. So let me substitute here 441. A1 over the area of the second trapezoid, which is 441, equals 12 square is to 21 square. And you can cross multiply to find the area of the first one, which is nothing but, by cross multiply, I'll have A1 equals 441 times 12 square, 441 times 12 square, and further I have to divide by 21 square. So let's simplify that. 441 times 12 square is nothing but 63,504 divided by 21 square gives us area of the first one as 144. Area of the first trapezoid. This will give me A1 equals 144. And we know the unit was square inches. Okay, areas will have square of the units, and the side lengths or perimeter will have the units itself. So these two are trapezoid. What is the area of the smaller trapezoid? And we found it to be 144. I hope these kind of problems are clear to you. Let's see the next slide. I want you to try this one. It's exactly similar. We want corresponding side this time. I want xy when the areas are given. Okay, try this problem. Call this as problem number 2. And once you have the answers, you may use chat. Okay, let's go over the solution for this. Here the area, let me call this as A1 and let me call this as A2. Okay, A1 is to A2 will be equal to the corresponding side. Pick up any side which is given here, 24. 24 square divided by corresponding side square, xy square. Okay, from the previous theorem, A1 is to A2 will be equal to 24 square over xy square. A1 is given to us as 252 square inches and this is given as 28 square inches. Okay, square inches will get crossed out, so we'll have 258 over 28 equals 24 square over xy square. Cross multiply further, you'll have xy square times 252 equals 28 times 24 square. Okay, you are finding xy, so first thing is divide by 252. Divide by 252. Let's simplify this in calculator here itself. 24 square times 28 divided by 252 gives us 64. So I get xy square equals 64. And taking square root on both sides, I get xy equals 8. Okay, once I have the xy, let's try one more problem here. This one I will try to go ahead and work same way here. This is your area 1 and this is your area 2. Area 1 is to area 2 equals the side which is given square divided by the corresponding side square. Corresponding to 10, I have xy. So xy square. A1 is 208 and A2 is 468 equals 10 square over xy square. Cross multiply once again, so you'll have 208 times xy square equals 10 square times 468. Further divide by 208 on both sides. To get xy square equals 10 square is nothing but 100. So 100 times 468 divided by 208 gives us 225. And taking square root, we should get 15 as the required answer for xy. So I get xy equals 50 centimeters. Okay, because the unit was in centimeters and here in the previous one the unit was in inches, so this xy should be 8 inches. Okay, let's move on to the next slide. Area of triangle ABC and triangle DEF are similar. The height of triangle ABC is 30 inches. The base of triangle DEF is 8 inches. The area is 40 square inches. Find the area of triangle ABC. Okay, I want you all to try this particular problem. I'll assist you in another minute and a half. Here the information given is not consistent, but there is a hidden information based on this one. For the second triangle I have area. So triangle, let's draw triangle ABC first. Triangle ABC. What is given to us in case of triangle ABC? The height is given, this particular height is given as 30 inches. Okay, let me draw triangle DEF. Okay, these are not to the scale, I'm just drawing. The base of triangle DEF is 8 inches, so I have this particular base which is 8 inches EF. Let me take EF as base, 8 inches, and I have been given the area here is 40 square inches. So the information is not consistent. Had I got this height, then I can compare the height 1 square divided by height 2 square equals area of this particular triangle A1 to A2. Let's find out the height. I can find out the height because I have the base and I have the area. So here height is going to be half of base times height equals area, which is 40. Half of 8 times height equals 40. If I further simplify this, 2 times 4 is 8, so you'll have 4h equals 40 and h equals 10. So I'll have 4h equals 40 and h equals 10. So this particular height is 10 inches. We can write here for triangle area of triangle ABC divided by area of triangle DEF, we know that they are in the ratios of side square, and it's also true for the height. Okay, so we can keep here height square. Height here is 30 square inches, and in this case it is 10 square inches. I have not been given the area of triangle ABC, but I have been given the area of triangle DEF. So I can write this as 40 square inches. So area of triangle ABC divided by 40 will be equal to 30 square over 10 square, and I can cross multiply. So you'll get area of triangle ABC as 300 times 40 divided by 100, because 30 square is 900. 900 times 40 divided by 100. So area of triangle ABC equals, I am not simplifying, but you should be able to make out 40 times 30 square you can do, which is nothing but 40 times 900, and divide by 100 to get answer as 360. 360 square inches as the area of triangle ABC. I want you all to try same with this particular problem, the second one. The dimension of a rectangle are 8 centimeters and 12 centimeters. So let me draw the first rectangle. 8 centimeters and 12 centimeters. They have given you this. What is the dimension of the similar rectangle which has area which is double of this particular area? I have another rectangle, and here area equals twice of A. Here A equals, area equals 8 times 12. Okay, and you are finding dimensions of the similar rectangle. You are finding here what is the width and length of this particular rectangle. 8 times 12 is, this area is, the first rectangle area is 96 centimeter square, and the area of the second triangle, second rectangle is 2 times of 96, which is 192 centimeter square. And we have 8 square over W square equals 96 over 192. Same way I can also say that 12 over L square equals 96 over 192. But we don't have to do this part. If we do one of them, we can use the area formula and find the, length. Okay, we will cross verify. First let's find the W square. So here W square is nothing but cross multiplying 8 square times 192 divided by 96. This is what you will get once you rearrange, cross multiply all that. Okay, so here 8 square is 64 times 192 divided by 96 gives us 128. And taking square root of 128, I get 11.31, 11.314. So I get W equals 11.314. Same way I can find L square, or I can use area's formula here. Area is for this one is 192. 192 divided by 11.314, I should get the length, because length times width is area. Or you can just use this as well. We will cross verify in case if you want to. So here in this one, L is equal to 192 times 12, L square equals, divided by 96. It should be 192. 192 times 12 divided by 96. So I get 192 times 12 divided by 96 as 24. So L square equals 24. Wait a second, here it should be 12 square. That's the reason. So 12 square. So 192 times 12 square divided by 96 gives us 288. And then taking square root of 288, I have 16.971 as the length. You just go over this once more later. I hope this is clear. And you can also see here 192 divided by 192 divided by 11.314 should give you 16.971, similar number. Okay, there might be some decimal error in the third decimal, but it will give you same number if I just do 192 divided by 11.314. Rhombus RSTU and rhombus VWXY are similar. The area of RSTU is 384 square feet. So area of RSTU they have given, and whenever we have area we compare it with the other area. So I'm just writing ahead VWXY. The area of RSTU is 384 square feet. The diagonal of VWXY is 24 feet long and 18 feet long. Find the area of VWXY. Okay, then use the ratios of area to find the lengths of the diagonals of RSTU. Okay, so first let's find the area. Area of VWXY, the rhombus, is nothing but we have the formula as half of product of the diagonals as the formula for areas of the rhombus. Here they have given us the rhombus as the rhombus with diagonal 24 feet and 18 feet. So 24 times 18 divided by 2 will give us the area, which is 260. Okay. And the same way as we had side square, the areas of RSTU VWXY will also have this diagonal, will satisfy this. Okay. Diagonal of the first diagonal square. Okay. By this I mean we had area of RSTU, which is 384 square feet, divided by area of VWXY, which we found was 260, will be equal to, in case of VWXY, let me call diagonal 1 as 24 feet. 24 feet square. In this case, I have not been given the diagonal for RSTU, so I'll just keep it as T1 square. I can cross multiply and find the diagonal of this particular rhombus. So that gives us 384 times 24 square divided by 216 as the basic diagonal square of Robus RSTU. 384 times 24 square divided by 260 gives us 1024. So diagonal 1 square equals 1024. Taking square root, I get diagonal 1 equals 32. Unit was in feet, so just keep 32 feet. I can find the other basic diagonal using the same formula, or I can use the area. So we know the area. This time let me use area. We are seeing area for rhombus, area of RSTU equals half of diagonal 1 times diagonal 2. They had given the area of RSTU as 384, so just keep this as 384 equals half of, I have the diagonal one which I just now found, 32 feet, and I don't have the diagonal 2. Okay. Let's further simplify this. 384 equals 32 divided by 2 is 16, so 16 times diagonal 2, then dividing by 16 on both sides. 384 divided by 16 gives us 24. I hope this is clear to you. Let's move on to the next slide. Okay, the triangle ABC and triangle DEF are similar. This is the symbol used for similar. Use the information below to find the all possible values of x. The area of triangle ABC is 5. The perimeter of triangle ABC is 2. Okay. The area of triangle DEF is x square plus 9. The perimeter of triangle DEF is x. Okay, all of you just try this particular problem. We will go over solution in another minute or so. Let's go ahead here. I have triangle ABC, area is 5. At triangle DEF, the area is x square plus 9. Perimeter of triangle ABC is 2 square. At perimeter of triangle DEF is x square. We have this particular relation from the previous things that we have learned, and we can further cross multiply and simplify. Here I'll have cross multiplying 5 times x, I get 5x square equals 2 square is 4, so 4 times of x square plus 9. So I get 5x square equals 4x square plus 36. Subtracting 4x square from both the sides, I get x square equals 36. And taking square root on both sides, I get x equals plus or minus 6. Okay, clear? Let's move on to the next one. What is the ratio of the area of the shaded triangle to the area of the unshaded triangle? Okay. Let me call this as A. Let me call the area of this one as A1 and this as A2. We know that area of A1 is to area of A2 equal to, they are just asking us the ratio, they are not asking us to find the areas. we just have to pick up a corresponding side. Okay, for I have the corresponding sides 10 and 15 given. 6 is given here but this corresponding side is not given. 10 is given here but the corresponding side here is not given. So I can pick up these two sides. So 10 square over 15 square. I can do here 10 square over 15 square. So I'll have here 100 divided by 225. Further I can write this as 100. I can simplify based on 5 to get here 20. 5 times 20 and 225 divided by 5 gives us 45. Further I can simplify, this is 5 times 4 and this is 5 times 9. So the 5 I can't further simplify. I have 4 and 9. I can't further simplify, so the ratio is 4:9. So ratio is 4:9. Okay. I hope this problem is clear. Let's move on to the next slide. Okay, this will be our last slide, and after that I'll give you time to work asynchronously. An isosceles trapezoid has a base angle 60 degrees and 120 degrees. If one base is 10 centimeter and the other base is twice as long, find the area and perimeter of the trapezoid. Okay, find the area and perimeter of the trapezoid. I'll give you like a minute or so and then we will go over solution. Okay, you may need help on this one, so please observe. They have given one of the base as 10. I've drawn an isosceles trapezoid. One of the base is 10 units, the other base is 20 units, which is twice the one of the base that is given. If this is 20, let me draw a perpendicular from this particular end of this particular base to this one, and let me drop another perpendicular here. Okay. Once I drop, which means this particular length is 10. This, because it's I'm dropping a perpendicular. This distance is 10, and the total distance from this end to this end is 20, and this is isosceles trapezoid. So the remaining portion gets split exactly half. So 20 minus 10 is 10. So we have 5 units as this particular portion, and this also has 5 units. The ones that I'm marking in green will be your 5 units. And I have this particular angle as 60 degree and this as 120. And using our Pythagorean theorem, I can find this using our trig ratios, I can find this particular hypotenuse and opposite side. I've been given adjacent. Okay, I can use by cos 60 degrees. Cos 60 degrees is nothing but adjacent over hypotenuse. Here hypotenuse, this is your hypotenuse. I will leave this, and once I have this hypotenuse, this is same as this particular hypotenuse. It's isosceles trapezoid. Adjacent was 5. Hypotenuse I didn't know, so I'm just keeping it as HYP. And cross multiplying, I can get HYP equals 5 divided by cos 60. Make sure your calculator is in the degrees and not radians. And you can get the value of the hypotenuse. 5 divided by cos 60. That gives us 10. I got hypotenuse as 10. This is 10 and this is also 10. I can find opposite using trig ratios, or I can find it using Pythagorean theorem as I have this as 10. Let's use trig ratio itself. I'll have opposite and adjacent. This is your opposite corresponding to 60 degree and 5 is adjacent. I can use tan 60. I can use tan 60 equals opposite here is the height of this particular trapezoid. I'll just write opposite here and divided by adjacent, which is 5. So cross multiplying further, I get opposite equals 5 types of tan 60. Okay, I'll just write OP, otherwise it will get confused to 0. So opposite equals 5 types of tan 60, which gives us 8.66. 8.660. That's your height. So once I have all of this, I can find the perimeter, I can find the area. So perimeter is nothing but sum of all the side. This was 20 and this is 10 and this was 10 and this was 10. So perimeter is nothing but two bases. First base is 10, second base is 20, and this particular hypotenuse that we found 10 and 10. So I get answer as 50, and the unit was centimeters. Centimeters. To find area, you know the formula for area is half of h times of b1 plus b2. Here h is this particular, it's not the hypotenuse, it is the altitude of this particular trapezoid, which we found as the opposite, that is 8.660. And the two bases are 10 and 20, so 10 plus 20. And I have 129.9 as the answer once I simplify this. 129.9 centimeters square. Okay, a rhombus has an angle of 50 degrees and a longer diagonal of 20 inches. Find the area and perimeter of the rhombus. Okay, all of you try this particular problem. This will be the last problem, and then we will go over solution once again.